Let f and g be two functions defined by f of x equal to modulus of x plus mod x, g of x equal to 1 by x for x not equal to 0. What is if f of a plus g of f of a is 13 by 6 for some real a, then the maximum possible value of f of g of a. So, f of a plus g of f of a equal to 13 by 6. F of x is modulus of x plus mod x. When x is positive, x plus mod x will be twice of that. So modulus of 2 times x. When x is negative, x plus mod x will go to 0. F of x will be 0. Any negative x, f of x is 0. I like that. I want to keep that in my head. So g of f of x is not even defined when x is negative, because f of x will go to 0. G of 0 will become 1 by 0. Not possible. And so this question is kind of telling us, think of this whole thing for a positive, a being positive. And g of f of a plus g of f of a is 13 by 6, or f of a plus 1 by f of a is 13 by 6, or y plus 1 by y is 13 by 6, y square plus 1 is 13 by 6 times y, 6y square minus 13y plus 6 equal to 0, 6y square minus 9y minus 4y plus 6 is equal to 0, 6y into 3y into 2y minus 3 minus 2 into 2y minus 3 is equal to 0, 3y minus 2 into 2y minus 3 is 0, or y is 2 by 3 or 3 by 2. Whenever you are solving for this, the roots will be reciprocals of each other. If y equal to k works, y equal to 1 by k will work. So something you just keep in mind. So 3 by 2 or 2 by 3. F of a is 3 by 2 or 2 by 3. So f of a, which is modulus of a plus mod a, is equal to 2 by 3 or 3 by 2. We know that when a is negative, f of a goes to 0. This is not negative, it doesn't go to 0. Or 2 mod a or 2a is 2 by 3 or 3 by 2. Or a is 1 by 3 or 3 by 4. Nice. The maximum possible value of f of g of a. So a is 1 by 3 or 3 by 4. G of a is 3 or 4 by 3. 1 by x. F of g of a, 3 plus mod 3 whole modulus 6 or 8 by 3. The maximum possible value of f of g of a is 6, because 6 is more than 8 by 3. That's it.